This video gives a brief introduction to an algorithm for rectification of rolling shutter video. The algorithm was presented at the 2010 CVPR conference in San Francisco, California. This is an example of a movie captured with a modern cell phone, in this case an iPhone 3GS. As the video was captured while the owner was walking, the camera trajectory is jerky. If one looks carefully at the video, it also exhibits a bit of wobble. The wobble is caused by the camera having what is known as a rolling shutter. Here's an illustration of a rolling shutter camera. To the left we have a static scene. The shutter sweeps over the scene to paint an image. The captured image is shown to the right. Here's a dynamic scene instead. As can be seen, the captured image is distorted when the scene changes during exposure. We have developed an algorithm that can rectify rolling shutter video. The algorithm makes use of a sparse optical flow, illustrated here as green dots. The optical flow is computed between neighboring frames. Using the optical flow and rigid motion constraints, we solve for the 3D camera motion. This is different from previous approaches that do rectification directly in the image plane. As the 3D motion is the cause of the distortions, our algorithm requires fewer parameters to describe the distortion and is thus more robust. Based on the 3D motion, we can rectify a frame by transforming each image row to where it should have been if the camera had been stationary during exposure. As our algorithm also finds the 3D camera trajectory, a natural application is to also do image stabilization by making the trajectory more smooth. This clip illustrates the effectiveness of such a smoothing. To the upper left we see the original sequence from the iPhone. To the upper right we see the result of our rectification algorithm. In the lower left we see the result of stabilizing the sequence without the rolling shutter rectification. As can be seen, the result is not satisfactory. In the lower right, we see the result of applying both rectification and smoothing. As can be seen, the sequence is now stabilized.